Looking at, we're still doing our definitions. I have a feeling we want to try to get through this very quickly so that you guys can have some time to do the homework, right? Because we should have finished this yesterday, but we had a long discussion about things. So anyways, okay. So congruent segments. So when you have this little dash on here, that means it's congruent to any other segment that has that dash on there. So I could write down here that AB segment is congruent to what? To CD. Because those have the one dash. I could also write FG, segment FG is congruent to EG, which is also congruent to EF. I'm going to show you something that's a little bit weird right now. If I write FE is equal to FG, that is correct notation, but it means something different than what I just wrote. Anyone want to guess what that means? Yeah.
Their like number values are the same.
That's exactly right. Their number values are the same. So this congruent means that their parts are actually are exactly the same. Okay. So that's, and you'll notice that I said the segment, this segment's the same as that. So that means if I cut that segment out and put them next to each other, they're exactly the same. So that's congruent. This means their number value. Notice I did not put a segment line above it. When you don't do that, I'm saying the length from F to E. That's what that means. So this is a number. This is going to be congruent to some other part. Kind of weird. Okay. How about angles now? It's the same thing. This has one little curve. This has one little curve. So I can say angle. How do I say that first angle? Okay. So you guys said two different ones, but they're both right. So QRS, or I could have said SRQ for that, is congruent to angle. What did I do there? Why am I allowed to do that? How many angles is that? Y? One. So is it clear when I say angle Y? What I can't do next with that same logic, this would be a mistake, so you don't need to write this down, but I can't say angle I. Why can't I do that? Because I has three angles. So if it only has one angle, you're allowed to just say angle Y. You can, yes, you could have said angle R, absolutely. But this would have been bad. So tell me what's a congruent statement for these angles. Is congruent to angle KIJ, which is congruent to I already did HIK. It wouldn't be HIK because that would be this big angle. LIK. Okay. So really, we just need to know that notation. The one dash would mean anywhere else we see that one dash, that those are the same, or two dashes. What if I wanted to introduce another shape into this that wasn't equal to those other ones? How would I do that? Put three dashes. And if I wanted to, I could put four dashes, okay? And wherever you saw that, that means that's congruent, okay? So now we're going to actually do some problems from this section. Here's number one. You're going to take a second and write it down. Notice, or first of all, what's the answer to A? Do we know? Part A here, length of AB. Okay, it's definitely 3. And the length of BC, we'll get to that in just a second. Yeah, good question. There is not. What's
Wouldn't that be negative 3? I was just
lengths are always positive. So you go to a hardware store and you want a 6-foot board and you want a negative 6-foot board, they're going to look at you really strange. Okay, length is always positive. If you're driving your car backwards for 5 miles, is it still positive?
Yeah.
Yeah. Okay. You can't go a negative distance. What's the distance for BC? For the length of BC? 3. Okay. So you made a really good point. I didn't put a line over here. What's different from my question A and B, how I wrote it? This means a line segment. This means the distance. When you don't put that line above it, it means distance from B to C. Okay, so this is shorthand. I could have just written over here, tell me what AB is, and that answer would have been 3. And that means how far is A from B when you don't put the line above it. If I put the line above it, and this is all very, very particular, if I put the line above it, then I have to write the words length of. Otherwise, you're going, it doesn't mean it equals another number. I would have to say it's congruent to something else. Okay, because you're talking about an actual shape, which is a segment. And if I want to know how long it is, it's got to be 3. Okay. Weird, very picky. But if there's no sign over it, that means length. So what is a postulate for how to solve number 1? So what's postulate mean? It's a rule, right? So what rule could we make up for how to solve these problems? I mean, we could have just gone up here and said that that's just 1, 2, 3, and that this distance here was also 1, 2, 3. But can we make up a rule? If someone says, talking on the phone, you can't see the picture, they just give you the 2 numbers of the locations, what would the rule be? Okay. Okay, say that one more time.
-4 plus 3 is -1, and -1 plus 3 is 2 plus 3.
Yeah?
Couldn't you just like, if the numbers are negative,
Okay. Does it work if they're positive?
Yeah.
Okay, so there's the rule. What is it?
If they're positive, wouldn't you add them?
So if I want to figure out the distance from here to here, from 2 to 4, would I add those?
No.
What do I do?
You subtract.
You subtract them, okay? And if I subtract 4 and 2 and take the absolute value, it's 2. It also works back here. So here is basically the rule. You take the absolute value and we're allowed to just put any letters we want in there because we're saying generally. A lot of times in math, we like to use X and Y for unknowns. How do you feel about that? Okay, so we could put X and Y. So this should work for any problem that you can put absolute value of X minus Y. And the order of these actually don't matter. So if I'd said -1 and 4 in there, that's -1 minus -4, which is positive, which is -3, and then absolute value, or I could do it in the other order. Okay, but there's the rule. Good. Number 3. So if we looked in the textbook, there'd be this whole long explanation of how to solve this. I don't know about you guys, but I look at this and it's pretty obvious to me, and I don't want to be offensive if it's not obvious to you, but it kind of just screams at me how to solve this problem.
Yeah.
Is it screaming at you? Okay, so what do you think? Yeah.
You add 3x minus 3 and 2x plus 4 equals.
Awesome. So it's giving us this information right here, the AC from here to here is 12. So it's pretty clear to me that if I add these two parts, that those two parts equal 12. Did that jump out at you?
So if we're writing that out, when we're solving it, we would do AB segment equals 4, or just be AB and then equals 4.
AB equals 4. Did you get that far? You're ahead of me. Okay, so we would say 3x minus 2 plus 2x plus 4 equals 12. Because they told us that this right here is 12. Okay? And if that whole length is 12, then you add those two lengths together. Yeah. Sure. X equals 2. Okay? So we could all see that this is 5x plus 2. And he did some work here. Do I need to show that work? You do want me to show you it?
Well, no, I thought you were talking about
Yeah.
we need to show it.
Honestly, if you did this on a test and it was correct, I wouldn't mind. Okay? If you did this on a test and it was incorrect, I would have a hard time giving you full credit, right? I'd have to figure out, you might lose points because I don't know what you were thinking. Okay? So the reason why you want to show all your thinking is so I can give you partial credit. If you went from here to here and you were correct, you'd probably be okay. But if you didn't show me any of this stuff here, and this was wrong, you got 3, then there's no way I can give you any partial credit because I don't know what you did wrong. So to be safe, and I know I can see some of you going, man, I love writing nothing down. And I'm not going to point fingers or name names.
Pretty good with making us write stuff down. Otherwise, we would lose points.
Right. So as we get further in our, when you get to calculus, they're not going to expect you to write. They're going to expect you to go from here to here and be okay with you just doing that. Okay? They're not going to expect you to write that down because you're going to have a ton of stuff to write down for every problem. Okay? When you get to calculus, one problem is like 2 or 3 sheets of paper. So if you don't show every step, they don't want you to, because then those 2 to 3 sheets of paper become like 6 or 7. You should take calculus, algebra 2, freshman, pre-calculus, sophomore, calculus, junior. You won't skip. I don't think you'll skip pre-calc. I don't think so.
Yeah, if you took AP classes.
You don't want to. Skipping 7th or 8th grade probably wouldn't hurt you that bad. Skipping pre-calculus, you'll be like, I have no idea what you guys are talking about. Okay? All right. So we found one part of our solution. Okay? The biggest mistake people make that makes teachers extremely frustrated is when they get the solution and they move on and they don't answer all the questions. The other parts of the question, it's saying, tell me what AB equals and tell me what BC equals. And Miss McCarthy might yell at me if I say, if you just put down the solution and it's right, I'm not going to fuss. Okay, what do we got? Okay, were you able to do that just by looking at it and popping it in? Okay, if you need to write it down, write it down. I have a degree in mathematics. If I was doing this problem for a test, I would write it down because I'm less likely to make a mistake if I write it down, okay? And I'm basically like a genius. No, not really. Okay, number 4. Sorry there's so much writing in this.
This is not even close to how much Ms. McCarthy made.
Oh, really?
Like, you yeah.
Did she give as much homework, though?
No.
She gave us a lot of time during class, and she gave us homework every night.
Well, Ms.
No, Miss,
McCarthy,
not
she
every
gave us homework every night, but it wasn't like a lot. It was like 10 questions. It's
On Friday. No homework on Friday.
Yeah, no homework.
Unless you didn't do something in class.
Yeah,
Gotcha.
And then you got homework.
That's your.
Well, I was talking to my wife last night, and she said I was a meanie pants.
Yeah, you're a meanie.
But I did the math, and I figured out if you spend the time in class, it ends up being about 30 minutes a night.
What if you're confused?
Yeah.
What if you want after?
Well, that's the nice thing about having time in class, is hopefully you get that confusion out.
Just do the weekend you do.
The other thing is some people yesterday told me that, and you get the weekend, but some people told me yesterday they would have a hard time getting it done this weekend. And what did I say? Andrew, right?
Yeah, it was me and Rachel.
And what did I tell you, Andrew?
She said we could do it next Sunday.
So you're going to have, it's not going to be hard to convince me to push it back the due dates. Here's the danger of pushing back due dates. It doesn't mean I stop assigning new problems, okay? So if I give you a full month and you wait till the last day on that full month,
No matter,
You're
that's 3 problems.
you are screwed.
Have fun. I've done that before.
We are going to use our protractors on these. It's in this. I only have so many of that one kind.
I kept mine safe.
If you had left it, I just put it in the bin.
I put it. Wait, are we looking?
The thing about
You can,
they give homework
but
in
you can
class,
live
and
here
it's
too.
like, you write 2 essays, and then don't have homework for 2 weeks, and then grade like 5
Sixth grade was easier.
No, sixth grade, I had more homework than I had in seventh grade.
Yeah, we had the ones in sixth grade.
Oh my god.
Especially grade.
Anybody go to Hayes? Who was your math teacher in sixth grade? You remember?
Yeah.
I had to write every single letter.
Was it Jameson?
No, and
Anyway, I had to write.
All right, so to measure these, okay, I always explain it that, and I don't like something about this protractor, but it's almost like there should be another line this way on it. There should be like a little X here. And I say we're going to land that plane at the vertex. So if I want to measure APB, I'm going to land that plane right there. One of the numbers needs to be at 0, or one of the sides needs to be at 0. Okay, and the other one is going to run through where the answer to that is. Now, you freehand drew this, or you did some, your angle might be a little bit different than mine. That's fine. But what is mine? And there's 2 numbers there. Why are there 2 numbers? Yeah. Right. So you could actually measure, if I extended this line, this is the one angle for this, but for this angle, mine is what? What's it look like? Okay, if you could see it better, it looks like it's about 34 degrees. What do you think that M stands for? It's the measure, right? So just like I have to say this angle is like a shape, I have to put the letter M in front of it to say the measure of that. Okay? So then the measure of angle APC for me is at 97, it looks like. And the measure of angle APD for me, what would be the wrong answer that a lot of people might say? Okay, they might say 40, which would be wrong because they're using the wrong number. You got to go all the way up. That's mine's 139. Okay? Yeah. Sure. So without using a protractor, so all of a sudden I rip this out of your hand and you start crying and I say, I don't care. Can we figure out the measure of angle BPC? So this one right here.
Wouldn't that be PBC, or does it really not matter?
Say it one more time.
Wouldn't it be PBC?
PBC would be this angle, would be PBC, would be this angle right here.
So it's the second one.
So the middle part is the vertex.
Oh, okay.
Okay. Why can't I say angle P? Because we have multiple angles. Good. So how can I find that? Well, if I look back at what I just did here, angle ABP is 34. Angle APC, which is this large one right here, is 97. Now notice that I have one arc and one arc, and sometimes that means congruent. Why do we know that this doesn't mean congruent? Yeah.
Because one of them for a little bit, and one of them had to do with it.
Right. And if I put a number here, okay, I'm saying that part. So it's kind of weird that we use similar notation for the same thing. Okay.
Wouldn't AP would that be like going through that the line segment of B?
It is. That's why I made this arc so big.
Okay.
Right. Had I stopped it here, yeah, you would go, what are you doing? But I didn't. That's why that continuous arc goes through there. Good question. Okay. So now, can you solve what this angle here is with that information? Is it 63 degrees? I think it is, but how did he solve that? Okay. So he saw that if I took this chunk off of this, okay, then that would be what's the remainder. So he said, okay, well, 97 is the large angle, and I did minus 34, which is the smaller angle, which leaves over this bit right here. Okay, does that make sense? It's like the segments we just did, but it's a little harder to see because of the, there's a lot more going on in the picture. So the next question says, what is CPD? They want to know what that part is. Well, it's helpful that I know what APD is. So APD is this whole large angle. Notice I made that arc go through all the way through there, and that's 139. Go ahead. Would it be 42? How do you get that? 139 minus 97, absolutely gives you that 42. Okay. Anybody not seen how to do that?
Why do you not subtract 34?
Because 34, this 97 includes this part of the 34.
So you have to subtract the 34 and
Right, you could have said, well, I know that this is 63, and you could go 139 minus those two. Okay. And then, so they might give you all these different numbers and ask you to do some subtraction or whatever it may be to find all the different parts, or they could ask you to add things to get the different parts. Okay. Number 5, number 6. We have 7 problems total. You might notice that, hey, you skipped number 5. That's because in the textbook, there's a sample number 5, which we're skipping. So I wanted your notes to correspond to the textbook. So if you go online and you're like, wow, I'm confused about my number 6 in my notes, it corresponds to number 6 from the textbook. It's less, it's more, is this slanted? I have this more than 90 degrees. Does that answer your question? Yeah. So I want to tell you the disadvantage of being pretty smart. Okay? If you're in this room, you're pretty smart. Okay? I want to tell you the disadvantage of being pretty smart. You will someday get to a point where things are going to get hard. I promise you. Okay? So the disadvantage of that is you're not used to things being hard. Okay. I'll tell you that when I've taught geometry in the past, I could show somebody this shape of this really cute kid. Okay. And I could say, what's the name of this shape? And they really struggled with naming it. And I would even say to them, what shape is this right here on the top? And they would really struggle with telling me that. Okay? Because they just couldn't see it. I think that I could probably show you this problem and say, go ahead and just solve it. And at least half of you would be able to solve it. And the other half would be able to solve it if I told them two or three things. The reason I'm telling you all of this is because if you struggle, when you struggled, the steps that you need to take is to figure out everything that you know and then start building from there. Okay? So if you were struggling with this point, I would tell you, well, what does this mean? Okay, that's a whole angle. So I would tell you to go ahead and write down that this whole angle is 95 degrees. Okay? And a lot of you could probably do this without even writing any of this down, but we want to get to the experience of just gathering the information so that when things get hard, we're good at that. What does this mean?
Oh.
So we also can say, oh, that's 35. Now we might have gotten stuck, but that's the kind of stuff we want to say is like, what does that mean? What does this mean? What does that mean? So now that I haven't even looked at what the question was. Now I'm going to look at the question. The question's saying, what is MBL? So they want me to answer, what is this angle right there? Okay, and just so I'm not confusing myself, I'm going to put two dashes through it to say that it's what? It's different. Yeah, and what do you get? Okay, so I hear 25. I say that's correct answer. Life's good. Someone shows their work but gets the answer 24, they get partial credit. You put 24 here, I give you no credit. What would be the work that we would show?
I would subtract.
Okay, what did you say back there? Okay, so you could do add the 35s, or you could just go minus 35 minus 35 and say that that's 25. Okay, good. And then finally, this is the last problem. Do your best with drawing this.
If we can find out in one of those.
That's good.
The two. Z's, I draw Z's like this so that you can tell the difference. What's this? That's a 3. Is it because I wrote it bad or because you can't see very well? Okay. You're saying I wrote it bad.
Why are you judging the teacher, Brady?
Wait, what is that?
I'm doing the best that I can. Is
Bottom middle.
that better? This is an E.
Oh, I knew that was an E. Okay.
Come on.
Wait,
Come on, guys.
Now you're just being mean. Where is there even a 0? Or is that just what it's?
He asked me if this was a 2.
All
Okay.
And I said, no, this is a Z. This is how I would.
So now, I mean,
What's that?
I don't, now all you do is go around the top segment, right? That has segment.
It does. So here's,
In that middle.
right. So here's the thing. It says find all known segments. Okay. So what segment do we know? I can say that AB is 3. Okay. I can also say what? You can do that, but I'm looking for lengths here, and I was not clear on my directions, but you're right. But let's just do lengths. BC equals 3. Oh, I did that wrong. Bad, Mr. McConnell. BC equals 3. I shouldn't put the line above it. Sorry. What else? CD equals 3. So now we're just listing all the information that we can. DE equals 2. EF equals 2. Awesome. So there's only one more. There's only one more that we actually know what the length is, and that's CE equals 5. Here's a mistake in geometry. I don't know what this length is, and I don't have enough information to figure it out.
Because 3 plus 2. Oh.
I don't know what this is, and I don't have enough information to figure it out. So I can't say anything. I do have enough information to figure out that because it was adding those together, and that gave me 5. Okay. You will be tempted in geometry to give me answers to things, and I'll say you don't have enough evidence for that. Now, for half a second, I debated when I gave you these notes to make this a right angle. If I made that a right angle, then you would be able to tell me what DF was. Anyone know how?
Oh, I agree.
Pythagorean theorem. For AC, yes. Okay, but here's the thing. I did not tell you that this is 90 degrees, so you cannot use Pythagorean theorem. This might be 89.5 degrees. Or it could be 90.1. It could be super close. Okay? If I don't give you the information, you can't assume things. There's a number on your desk. That number corresponds to your Chromebook number. Okay? I'm not really worried in this class, but I have to tell you that the number on your desk, if something happens to that Chromebook, you're responsible for it. Anything you do or say will be held against you in the court of Mrs. Carr's office. Okay. But anyways, that's your Chromebook number. You don't have to memorize it because it should be on the desk every day. We have not as much time as I wanted to, but we have 14 minutes to work on the Chromebook. Yeah.
So how do you solve what you said?
You just can't.
Oh, okay.
Okay.
I will spell, like, add all the compound things there.
You should have. Come on.